Good morning, students. Today I am going to explain you an experiment from the organic chemistry, that is the detection of extra elements in the given organic compound. Now, as all of us know, organic compounds contains carbon, hydrogen and oxygen as in main elements. So these are the elements which are assumed to be present in the organic compound. But besides that, other elements may also be present. For example, nitrogen, sulfur, halogens, that is chlorine, bromine and iodine. So these are the extra elements which can be present in the organic compound. Now to detect these extra elements, we have to prepare the LASSAIGNE'S extract, and the test is called LASSAIGNE'S test. In that we fuse the organic compound with the sodium metal so that the elements get converted into water soluble sodium salts, which are then used to carry out the reactions. Now you can ask me that why we are performing the test by preparing the extract first. Why can't we perform the test directly with the compound? Okay. The reason behind this is that the elements are present in the covalent form in the organic compounds. So we need to convert them into ionic species because these are the tests for the ionic species. So these extra elements are then converted into ionic species by fusing them with the sodium metal, and then we perform the test with these ionic species. Now, what are the ionic species which are present in the LASSAIGNE'S extract? If your compound contains nitrogen, then you can see in the slide, it is present in the form of sodium cyanide. If the compound contains sulfur, then it is in the form of sodium sulfide. If the compound contains nitrogen and sulfur both, in the extract you will have the sodium thiocyanate, and if the compound contains halogen, then you have the sodium halide. Sodium halide means if it is chlorine, then sodium chloride, bromine, then sodium bromide, and iodine, then sodium iodide. Now we have to do the test individually. So first will be the test for the nitrogen. For that we will take 1 to 2 ml of the sodium extract, and to this extract we add freshly prepared ferrous sulfate solution. A dirty green precipitate of ferrous hydroxide is obtained. Now this is a must. We must get the dirty green precipitate of this ferrous hydroxide. If you are not getting any precipitate, in that case you have to add 2-3 drops of dilute aqueous sodium hydroxide to get these precipitates, and then you have to heat the tube gently with shaking for 1 minute, followed by addition of dilute sulfuric acid. A Persian blue color is obtained, which indicates the presence of nitrogen in the given organic compound. Okay. Now what are the reactions which are involved in this test? As we are adding ferrous sulfate solution into the tube, and the sodium hydroxide is already present in the extract. Now how sodium hydroxide is already present in the extract? Because you are fusing the compound with the sodium metal, and then you are plunging it into the distilled water, so that unreacted sodium metal will react with water to give sodium hydroxide. So in the LASSAIGNE'S extract, sodium hydroxide is there. It will react with the ferrous sulfate to give dirty green precipitate of ferrous hydroxide. That is why I told you that if you are not getting any precipitate, that means here the sodium hydroxide is not present, because ferrous sulfate you are adding from outside. So you have to add sodium hydroxide so that you get the green color precipitate. Okay, then this ferrous hydroxide react with the sodium cyanide. What is the sodium cyanide? It is the nitrogen is present in the sodium cyanide form in the LASSAIGNE'S extract. So this sodium cyanide then reacts with ferrous hydroxide to give sodium ferrocyanide. And this sodium ferrocyanide then reacts with ferric sulfate to give ferriferrocyanide complex, which is Persian blue in color, which indicates the presence of nitrogen. Now the question arises, we have not added any ferric salt into it. So from where this ferric salt comes? In this test there is ferric sulfate. So from where this ferric sulfate comes in the reaction? Now since you are heating the aqueous solution of ferrous sulfate, so by that heating, we are converting the ferrous ion into ferric ion, and this conversion takes place by aerial oxidation. So therefore, we are getting ferric sulfate, and this ferric sulfate then reacts with the sodium ferrocyanide to give ferriferrocyanide complex, which is Persian blue in color. Okay. Now the next is the test for sulfur. Now to test the sulfur, we have to perform the sodium nitroprusside test. For that, we have to take 1 to 2 ml of sodium extract, and to this we have to add 1 ml of freshly prepared sodium nitroprusside solution into it. Violet color is observed, which indicates that the sulfur is present in the compound. And the reaction for the sulfur test is that now the sulfur is present in the which form in the extract? In the sodium sulfide form. So the sodium sulfide reacts with sodium nitroprusside to give sodium sulfonitroprusside, which is violet in color and therefore indicates the presence of sulfur in the given organic compound. Now the third is the test for nitrogen and sulfur present together. There is a possibility that the compound may contain both nitrogen and sulfur. Now one example is thiourea, where you have both the nitrogen and sulfur in the given organic compound. So how you can test the presence of both in a given organic compound? For that you have to take the sodium extract 1 to 2 ml and then you have to acidify it with the dilute hydrochloric acid. Then you have to add 2-3 drops of ferric chloride solution into it. A blood red color is obtained, which indicates that the nitrogen and sulfur are present together. Now the reaction for this is, now nitrogen and sulfur, when they are present together, they are present in the form of sodium thiocyanate. So this sodium, as you can see in the slide, the sodium thiocyanate react with ferric chloride to give ferric thiocyanate, which is blood red in color. So the blood red color is due to the formation of ferric thiocyanate. So that blood red color indicates that your organic compound contains both nitrogen and sulfur together. Now there is a possibility that your compound contains both nitrogen and sulfur and you are not getting this blood red color. That means you are getting this test negative. Now this is because when you are fusing the organic compound with the sodium metal, you are fusing it with the excess of sodium metal. So instead of getting sodium thiocyanate, you are getting the sodium cyanide and the sodium sulfide. As you can see in the slide, the sodium thiocyanate on reaction with the sodium metal gives sodium cyanide and sodium sulfide. And sodium cyanide is the sodium salt of the nitrogen which is present in the LASSAIGNE'S extract, and the sodium sulfide is the sulfur form of the compound which is present in the sodium extract. So that means instead of getting the combination test positive, that means instead of getting the blood red color, you will get the individual nitrogen test and the sulfur test positive. That means if your compound contains nitrogen and sulfur together, there are two options. What is the first option? That you will get the nitrogen test negative, you will get the sulfur test negative, but you will get the combination test positive. That means you will get the blood red color in that. What is the second option? You will get the nitrogen test positive, that means you will get the Persian blue color for the nitrogen. You get the sulfur test positive, that means violet color in the sulfur test, but you get this combination test negative. So whatever is the observation, the inference remains the same, that your compound contains both nitrogen and sulfur. Now the next test is the test for halogens, which can be performed by the two ways. One is the silver nitrate test, another is the layer test. And the silver nitrate test further can be carried out by two ways depending upon whether your organic compound contains nitrogen or sulfur or they are absent in the compound. Now firstly we'll discuss the silver nitrate test, and that too when the nitrogen or sulfur both are absent. Then how we can perform the silver nitrate test? For that we will take sodium extract 1 to 2 ml, then we acidify it with dilute nitric acid and then we'll add 0.5 ml of silver nitrate solution into it. Precipitates are formed, which indicates that halogen is present. That means if you are getting any precipitate, that means halogens are present, and if you are getting no precipitate, that means halogens are absent. Now the precipitate can be of three types. That means you may get three observations in this test depending upon the color and the solubility of the precipitate. That is, if you are getting white precipitate, first observation is white precipitate which is soluble in ammonium hydroxide, then the chlorine is present. If you are getting a pale yellow precipitate which is soluble in excess of ammonia, liquid ammonia or ammonium hydroxide, that means bromine is present. And if you get yellow precipitate which is insoluble in excess of, even you take whatever amount of ammonium hydroxide, it is insoluble, that means the iodine is present. So depending upon what observations you are getting, you can find out that which of the halogen is present in your compound. Now the reaction for the halogen test, as you can see in the slide, halogens are present in the form of sodium halide in the LASSAIGNE'S extract. So the sodium halide react with the silver nitrate to give the precipitate of silver halides. So these three precipitates are due to the silver halide. If you are getting white precipitate, that means it is due to silver chloride. The pale yellow precipitate is due to silver bromide, and yellow precipitates are due to silver iodide. Okay. Now the second, I told you that silver nitrate test can be performed by two ways depending upon whether nitrogen or sulfur is present or absent. The first way we have discussed where both of them are absent. Now we'll discuss when both of them are present. Then in that case you have to take sodium extract 1 to 2 ml and you have to acidify it with 2 ml of, now here it is concentrated nitric acid. Okay. And then you have to boil the mixture to reduce the volume to half. Now with this reaction mixture you have to perform the silver nitrate test. That means now in the reaction mixture, you add silver nitrate and look out for the observations, which type of precipitate you are getting, so that you can find out whether the halogen is chlorine, bromine or iodine. Now, the first question which might come in your mind is that in the test for halogens, why we are performing this test, silver nitrate test, differently when the nitrogen and sulfur is present or when they are absent, and what is the difference is that we are heating the sodium extract with the concentrated nitric acid. Okay, so why is sodium extract boiled with concentrated nitric acid in the presence of nitrogen or sulfur? Now the reason behind this is that if the nitrogen is present, then it is present in the form of sodium cyanide, sulfur in the form of sodium sulfide. They interfere with the silver nitrate test. And how they interfere with the silver nitrate test? Just see into the slide. In the silver nitrate test, when you react sodium cyanide with the silver nitrate, you are getting the white precipitate of silver cyanide. If you can recollect, in the chlorine also you are getting white precipitate. Silver chloride is white color precipitate, and with the sodium cyanide also you are getting white precipitate. So you are getting the white precipitate due to the nitrogen or due to the chlorine. It is very difficult to distinguish. So we need to remove the sodium cyanide before performing the test for halogens. Similarly, sodium sulfide reacts with silver nitrate to give sodium sulfide, which are black color precipitate. And once you get the black color precipitate, it is difficult to see that other color precipitates are also obtained. Yeah, black is such a dark color, you can't visualize that other color precipitate. So we need to remove both the sodium sulfide and sodium cyanide before performing the test for halogens. Okay, and to avoid these side reactions, we have to heat it with concentrated nitric acid. Now, what is the role of concentrated nitric acid here? That concentrated nitric acid decomposes sodium cyanide into hydrogen cyanide, and we know hydrogen cyanide is a gas, so it will easily remove from the system. Similarly, sodium sulfide gets converted into hydrogen sulfide, which is again a gas, so can be easily removed from the extract. So now when they are removed, you can easily perform the silver nitrate test. Now, if you get any precipitate in the silver nitrate test, whatever color, white, pale yellow or yellow, whatever precipitate you are getting, then you have to perform the layer test. And the reason for this is that in the layer test is a confirmatory test. By the silver nitrate test, you can have the idea, yes, if we are getting the precipitate, that means compound contains halogens. But it is difficult to distinguish white precipitate from pale yellow to yellow. It is difficult to distinguish the colors. So we need to perform the layer test to confirm which halogen is present in the given organic compound. Okay. So how to perform the layer test? For that you have to take 1 to 2 ml of sodium extract. Then you have to add 1 ml of chloroform or carbon tetrachloride, followed by addition of 1 ml of chlorine water. And you have to shake the tube well. Now you have to look out for any change in the color in the organic layer. Now sodium extract, you know, it is aqueous medium. Yes, and you are adding chloroform and carbon tetrachloride into it. What are that? They are organic solvents. So you will get 2 different layers. Okay, so the 2 different layers are obtained. Now the aqueous layer will be colorless and you will get the color in the organic layer. Now here again you can get 3 observations. What are those 3 observations? If organic layer turns orange in color, it confirms the presence of bromine. If the organic layer turns violet in color, it confirms the presence of iodine. And if there is no color change in the organic layer, it confirms the presence of chlorine. Okay. Now what is the reaction for the layer test? Now you can see into the slide that the bromine is present as sodium bromide and iodine is present as sodium iodide, and chlorine water we are adding. So what is the role of chlorine water? It is acting as an oxidizing agent and it oxidizes bromide ion and iodide ion into bromine gas and iodine gas. Bromide ion is getting oxidized to bromine gas, iodide ion is getting oxidized to iodine gas. And these gases are soluble in organic solvents, so they give color. Bromine, what is the color of bromine gas? Yellow, orange. So orange color you get for the test for the bromine. Similarly, iodine gas is violet in color, so it gives violet color to the organic layer. Now that means since chlorine water here is acting as an oxidizing agent, so in place of chlorine water you can use any oxidizing agent. What are the various other oxidizing agents? For example, alkaline KMnO4, it is an oxidizing agent. Concentrated nitric acid is an oxidizing agent. So you can use any oxidizing agent in place of chlorine water to perform the layer test. So the theory part is over. Now I will tell you how to record it in your files. Okay. So first you have to write down the aim. So the aim is to detect the presence of extra element or elements in the given organic compound. Your compound may contain one element or it may contain more than one extra element. So this is the aim. Now the apparatus required, as you can see, china dish, funnel, test tubes, ignition tubes, capillary tubes, glass rod, wire gauze, pair of tongs, test tube holder, dropper and spatula. And if you want to see the details of the procedure, you can go through the lab demo. Then the chemicals required. The first is the organic compound whose extra element is to be determined. Then all the reagents which we have used in the tests. And then the procedure. Now in the procedure, the various steps involved are, the first one is the preparation of the LASSAIGNE'S extract, followed by the test for all the extra elements present. That means first the test for nitrogen, then the test for sulfur, then the test for nitrogen and sulfur present together, then the test for halogens depending upon whether the nitrogen or sulfur are present or they are absent. Now how to record the observations. So you have to make an observation table in which there will be 4 columns. One will be for the serial number, one will be for the experiment, one is observation and one is for inference. For example, you have to record the nitrogen test, then how will you record? In the experiment you will write down what experiment you have performed. That is, for example, you have taken 1 to 2 ml of sodium extract, then add freshly prepared ferrous sulfate solution. What was the observation? A dirty green precipitate is obtained. Now what is the inference? From here we can't infer anything. Why? Because in this reaction we can see that no nitrogen is involved. Nitrogen is involved in the second test. So whether you are getting, your compound is having nitrogen or not, since this is a reaction between the ferrous sulfate and NaOH, sodium hydroxide, sodium cyanide is not involved and therefore there is no inference. That means whether your compound contains nitrogen or nitrogen is absent in your compound, you should get the dirty green precipitate. And then heat the test tube and gently with shaking for 1 minute, you add dilute sulfuric acid, Persian blue color. You have to write on the Persian blue color in the observation and the inference will be nitrogen is present. Or what is the other option? That your compound doesn't contain nitrogen. So instead of Persian blue color, you have to write down, you won't get any color. So no color, nitrogen is absent. Similarly, you have to record the test for sulfur, the experiment which we have performed, then what you have observed and what is the inference. Okay. Same way with the nitrogen and sulfur present together. If you are getting blood red color, observation, then inference will be nitrogen and sulfur are present together. If you are not getting that no color, that means they are not present together. Then the silver nitrate test. Now, as I told you, silver nitrate test you can perform by 2 ways. So now till at this stage you know whether your compound contains nitrogen or it doesn't contain nitrogen or sulfur. So you can decide that you have to follow which path. Yes. If your compound contains nitrogen, then you have to follow the different path. If your compound doesn't contain nitrogen and sulfur at all, then you have to perform the different path. So whatever path you have followed, you have to record only that part, not the other part. Okay. And how you have to record? All the experiment part, whatever experiment you have done in the experiment, and in the observation, what are the colors you have observed, and the inference, what is the inference from that color. Okay. And then the layer test, again for the layer test, experiment, what experiment you have performed, what is the observation, as I told you 3 observations are possible. Now you have to record any one of the observation because you are getting any one observation. Yes, either your organic layer will turn orange or organic layer will turn violet or there is no color change in the organic layer. So whatever observation you are getting, record only one observation. Don't write down all the 3 observations, that no white precipitate or no color change in organic layer, no orange color, no, it's not like that. You have to simply write down only one observation and the inference for that particular observations. So this is about the layer test, and then in the end, so now the observation table is over. So now you have to conclude. So what is the result? That the given organic compound contains whatever extra element is present. For example, you are getting nitrogen and sulfur test together. So the given organic compound contains nitrogen and sulfur as extra elements. Okay. Now what are the precautions which you have taken into account? Now since you are using the sodium metal for the first time, so you have to be extra cautious for that, because number one, what are the precautions which you have to take into account? Do not touch the sodium metal with your fingers. Always use forceps or spatula to handle it. Never throw the sodium metal into sink. Unreacted sodium metal should be carefully decomposed by adding a small amount of ethyl alcohol into it. Don't throw it like that if it is not reacted, if your fusion is not correct, throw it into the sink. No, it is not a safer way. You have to fuse the compound with a small amount of the sodium metal with a small amount of ethyl alcohol, and then you can throw it. Now always use freshly prepared ferrous sulfate and sodium nitroprusside solution. fuse 4 ignition tubes per compound so that extract should be concentrated. Boil the extract with concentrated nitric acid when nitrogen or sulfur is present before performing the test for halogens, and you know why we have to follow this precaution. In the layer test, you have to shake the test tube well by putting the thumb on the mouth of the test tube, as you are carrying out the reaction between two different layers. Okay, so to carry, when you the two reactants should come close to each other to give the reaction. So how you can do that? By putting the thumb on the mouth of the test tube and then shake the test tube vigorously so that the two layers come in contact with each other and can give you the product. And always use distilled water. So what we have learned today? We have learnt about how we can detect the extra element in the given organic compounds, and what are the various extra elements we can detect: nitrogen, sulfur, chlorine, bromine and iodine. Okay, any questions?
Why we have to use distilled water in this experiment?
Okay. Now, as all of us know, tap water contains chlorine. So even though our compound doesn't contain chlorine, we get the positive test for chlorine. So to avoid that, we have to use distilled water. So here, the one precaution which you have to take into account is that whatever glass apparatus you are using, wash that glass apparatus first with the tap water, followed by rinsing with the distilled water. There should not be any drop of the tap water, otherwise you will get the chlorine test positive. Yes, any other question?
Why we shouldn't throw the sodium metal in the sink?
Yeah. We should not throw the sodium metal into the sink because sodium metal reacts with water exothermically. So that when the sodium metal come in contact with the water, it catches fire and it may explode. So to avoid such accidents, we should never throw the sodium metal into the sink. And it should not come in contact with the water. Okay. Yeah.
Ma'am, can we use dilute HCl in place of dilute H2SO4 in the nitrogen test?
Okay. Sit down, please. Now, as I told you in the nitrogen test, when we discussed the chemistry of the nitrogen test, that what is the role of dilute sulfuric acid into that? In the dilute, when we add the dilute sulfuric acid, the ferrous hydroxide and the ferric hydroxides become soluble in the dilute sulfuric acid. So with the dilute acid also they will get soluble and ferric salts will get converted into ferric chloride. But ferric chloride itself is yellow in color. So the Persian blue color, because of the nitrogen, and the yellow color due to the ferric chloride, gives the green color in the end. So to avoid that side reaction, that is to observe the exact color change, that is the Persian blue color, we should avoid this use of dilute HCl.
Ma'am, in the nitrogen test, we don't add any ferric salt. But how ferrocyanide is obtained as a product?
Yeah. The ferric ion we are not adding from outside the reaction, but they are present in situ. That means the ferrous hydroxide which is present in the LASSAIGNE'S extract, when we boil it in the alkaline medium, it undergo aerial oxidation to give ferric salts. So the ferric salts are due to the aerial oxidation of ferrous ions. Yes, any other question?
Why do we have to fuse 4 ignition tubes per compound to prepare the LASSAIGNE'S extract?
We are using the 4 ignition tubes because we want the extract to be concentrated. If the extract is dilute, we won't be able to test get the positive test even though our compound contains those elements. Nitrogen test is obtained only when the extract is highly concentrated. Halogens test, that too in the layer test, we need the highly concentrated LASSAIGNE'S extract. So to make the concentrated LASSAIGNE'S extract, we have to fuse 4 ignition tubes per compound. Any other question? Okay, so now we have to move to the lab to perform the experiment.